Greetings, everyone. Welcome to the talk on security and privacy of the portable document format. My name is Jens Müller. I'm a PhD candidate at the University of Bochum in Germany. And today I will give you an introduction to our current research, which is a joint work from Bochum on dangerous features of PDF. So in this talk, we will together dive into the maybe less known features of the PDF specification, which can lead to serious security flaws. So in 15 minutes, you may say, oh, I didn't know that PDF could actually do that. So here's an outline of today's talk. First, I'm going to give you some basic background information on dangerous PDF features, PDF actions, to get a better understanding of the attack to follow. Then I'm going to introduce basically 4 attack classes based on malicious documents that can lead to denial of service attacks, information disclosure attacks that leak personal data out of the victim's computer, the manipulation of data, code execution on the victim's machine. And finally, I'm going to provide an evaluation of those attacks on 28 popular PDF viewers, as well as some countermeasures for developers. Okay, let's start with some technical background. So when you study the PDF specification for interesting features, you will quickly stumble upon PDF actions, which are used for various purposes. So for example, to create external links or to navigate to a certain page within a document. Even JavaScript is basically a PDF action. And now all actions can be triggered using native PDF events, for example, when opening, closing, or printing that document. Most PDF actions can have a PDF file specification as a target, which could be, for example, a URL to find a hyperlink. So what we did here is we systematically studied the PDF specification for PDF actions and for events that can trigger them, and we tried to visualize this, resulting in my whiteboard being filled up like this mess. So here's the cleaner representation, and this is basically the most important slide of the talk. Basically, we identified 4 special PDF objects which allow to call arbitrary actions. We call those events. They are shown in the upper part. Each of those events can launch any sequence of PDF actions which are depicted in the middle part, and usually there are multiple alternatives to call an action. Now each target of an action can be a PDF file specification, which is a file handle, a multi-purpose object that could be an embedded file, so data stream within a document, a local file on disk, a remote URL, a network share, and maybe other possibilities depending on given parameters and context. Now, if a path from an event over an action down to a file handle exists and it's not blocked by the opening application, then this can be used for malicious purposes in some cases, like to access the file system or URL invocation, as we'll see later. Before coming to the attacks, let me quickly introduce the attacker model. So our attack scenario is as follows. The victim only has to open a malicious PDF document. So, and this is quite a realistic scenario because PDF is generally considered as relatively safe, and we all open basically PDF files from maybe untrusted sources, like we download academic papers from the internet and so on. Once the document is open, bad things happen depending on the attack. So, for example, in the denial of service attack class, the document would cause the viewer to consume all available system resources. Note that no other user interaction than opening that document is required. Let me come to the attacks. So I will give you today an example for each of the 4 attack categories. For more attacks, please refer to the paper. Let's start with denial of service. Let's start with how to create an infinite loop. So basically, we studied the PDF specification for self-referencing structure elements or other possibilities that lead to recursion or to infinite loops. And what is interesting is that each object within a PDF file can be referenced indirectly from another object. And this also holds for the action object, basically. Now, each PDF action allows you to specify a next parameter, so a next action to be performed. So in the given example, we have the next action that references to object number 5, but object number 5 is the object number of the action itself, okay, thereby resulting in some kind of an action cycle that keeps the consumer application busy forever. Another example is PDF object streams. So according to the standard PDF object streams, they may extend other object streams. So once again, we get some kind of cycle, and there are lots of more variants to keep PDF processing applications busy by forcing them into an infinite loop. Let me proceed with information disclosure attacks that leak personal data out of the victim's computer, like local files on disk, PDF form data, or even user credentials. So today I will show you an example how PDF documents can silently phone home. So in 2008, Eric Filial already showed how to use the open action event to trigger a UI action and thereby cause UI invocation in Adobe Reader. Now this path was quickly blocked and it won't work anymore in up-to-date PDF implementations. But if we try another path, for example, by calling the UI action from a different event, like from the additional action of a pages object, we can bypass existing mechanisms, protection mechanisms, for example, in Perfect PDF Reader. We can also use a completely different action, like the launch action, which we'll have a closer look later, and thereby we get URL invocation, for example, in Firefox. So it's somewhat obvious what we need to do here. We need to test systematically all possible passes. Okay, so all possible events, all possible PDF actions with a URL as the target of the file specification. And this resulted in 27 out of 28 PDF viewers silently phoning home in the background to the attacker's server, and can be somewhat privacy invasive, right? I mean, it can be used to de-anonymize reviewers, journalists, or activists behind a shared mailbox. Okay, our next attack class is data manipulation. It allows an attacker to modify PDF form values or to mask the displayed content of a document. I will today show you how to overwrite local files on disk. So similar to HTML, the PDF standard allows you to have forms. So form data, user input can be submitted to some web server, but it's not really a web server, it's actually a PDF file specification. And as we learned, that could also be a local file. So what happens if we automatically, using some automated event, post data to a local file on disk? It's some kind of ambiguity in the standard, and basically it allows you to overwrite local files on disk without any user interaction and purge their content. Okay, our last class of attacks is the execution of arbitrary code on the victim's machine by silently launching an executable from the malicious document. We do this using the launch action. What is the launch action? Well, the launch action is a somewhat special PDF action. According to the standard, a launch action launches an application or opens or prints a document. The standard does not provide any security considerations regarding this obviously dangerous feature. It even specifies how to pass command line arguments to the launched application. Therefore, it can be said that PDF somewhat offers code execution by design if the standard is implemented in a straightforward manner. So once again, what we do here is we test all possible PDF events, this time to call a launch action with the open parameter. Our target is an executable, could be provided maybe within the document itself or a local file. So let's see if in 2020 we can still find PDF viewers that do not ask the user before launching those arbitrary executables. So I have a quick demo here. This is really a straightforward implementation of the launch action with the open action event in Nitro Reader. And as you can see here, we can simply execute, for example, the CMD-exe. And this also works in some other views. Okay, let me come to a quick evaluation so you can see which PDF viewers are vulnerable to those attacks. So we tested 28 popular PDF processing applications, basically all PDF applications for the major platform, Windows, Mac, Linux, and web browsers. And now our evaluation shows that 26 out of 28 tested applications are vulnerable to at least one attack. For example, infinite loops in one variant or another, they are possible in almost any reader. The same holds for deflate bombs, so compressed data streams that consume all available memory when opened by the application. URL invocation, I already showed that 70 readers were directly vulnerable to this one. We could silently exfiltrate user input in PDF forms on 11 of the tested applications. On 6 applications, we could exfiltrate silently local files on disk, but for 3 of them, the file type is somewhat limited. We could exfiltrate NTLM hashes, so hashes of Windows user credentials on 12 of the tested applications. We could modify the user input into PDF forms directly when printing the document, which is somewhat nasty on 6 of the tested applications. For 2 applications, we could write to and overwrite arbitrary files. For 6 applications, we could display a completely different content in only these applications, while completely other content was displayed in all other PDF viewers. And yes, so for 6 applications, we had straightforward code execution by design without any limitations. So maybe the takeaway here is that virtually all tested PDF applications have some issues. And actually, PDF viewers that only implement a subset of the PDF standard, they're usually less vulnerable, like, for example, the Linux viewers. Okay, how to fix those issues? Well, to counter infinite loops, we should remove constructs that lead to cycles or recursion from the implementations, but also we should remove such ambiguities from the standard itself, if possible. This would also prevent content masking attacks. We could also try to limit the resources on the host level or the application level, so denial of service could not cause that much damage, or other attacks too. Our attacks are not depending on JavaScript, but JavaScript, we learned, provides really a large additional attack surface within PDF documents, so why not removing it? In my eyes, there's few real purpose for it. Finally, and most importantly, we think that secure PDF processing applications, they should basically identify and cut the dangerous path in a malicious document. So most of our attacks, they took a path from an event down to a file handle. And if this path was not blocked or required any kind of user consent, the attack was successful. Now, many applications, they blocked particular paths, but they failed to systematically block all of them. So there was no systematic protection approach. Okay, let me come to a conclusion. After studying PDF, we would say that PDF is not a simple document format. PDF is really complex, and it's a lot of interesting, but also maybe dangerous features. And applications that blindly implement the standard, they're somewhat flawed by design. So if you're the developer of a PDF processing application, be careful which parts of the standards you really want to implement. Not all of them are really required to view a document. And yes, in 2020, when we performed those tests, it was possible to get straightforward code execution based on pure logic chain exploitation in various popular PDF viewers. Okay, thank you. You can find all the artifacts and much more research on PDF security on the website pdf-insecurity.org.